remember that historic landing at the lunar South Pole, right? Well, a lot of people probably thought that was the finish line. But for India's space program, it was actually the starting pistol. That one moment kicked off this incredibly ambitious journey. And today, we're going to unpack the official government roadmap for India's next giant leap.
See, that success wasn't just about planting a flag and taking a victory lap. Nope, it was the green light. It basically unlocked a whole series of missions that are designed to build on each other, with each one getting more and more complex, all leading to one very specific, very big goal.
Okay, so take a look at this. And let me be clear, this isn't some wish list or a far-off dream. This is the official, government-approved timeline. We're talking about a mission to bring back a piece of the moon, India's very own space station, and then the big one, an Indian astronaut on the moon by 2040. It's a massive undertaking for sure. So how in the world do they plan to get there? Let's break down the very first stepping stone. The first major challenge, and it's slated for 2027, is a mission that's just unprecedented in its complexity for India. It's called Chandrayaan-4, and its job, simply put, is to go all the way to the moon, grab a piece of it, and bring it all the way back home. So that's the core objective. Now you might be thinking, haven't we brought back moon rocks before? And yeah, the US, Russia, and China have all done it. But here's the catch. No one has ever managed to grab a sample from the southern polar region. And why does that matter? Well, because the extreme cold and its permanently shadowed craters might have preserved ancient water ice and other materials from the very birth of the solar system. We're talking about stuff that could literally rewrite our origin story.
And here's where the scale of this mission just kind of hits you. The total spacecraft weighs a massive 9,200 kilograms. To put that into perspective, it's so heavy that even India's most powerful rocket, the LVM-3, can't lift it all in one go. And that right there creates a huge engineering problem.
So what do you do? Well, ISRO came up with this really ingenious solution, basically a cosmic relay race. They're going to launch the entire 5-module spacecraft in 2 separate pieces, on 2 separate LVM-3 rockets. Then those 2 halves will have to find each other, meet up, and dock together in Earth's orbit before they can even begin their journey to the moon. And this really shows you just how complex this whole dance is. I mean, follow the path with me. After that first docking in Earth orbit, the craft travels to the moon, it lands near a spot called Mons Mouton, robotic arms grab the samples, and then comes the really tricky part. For the first time ever for India, a module has to launch off the surface of the moon, dock again in lunar orbit, and only then can it send the samples home. Every single one of these steps is a high-stakes maneuver, where even one tiny thing going wrong could jeopardize the whole mission. Now, to pull off a mission this heavy, ISRO can't just use its standard rocket. They need a serious power upgrade. And that introduces a major hurdle for this whole roadmap. It's a high-stakes race between developing a brand new engine and a very, very tight deadline. The key to it all is this, the new SE-2000 semi-cryogenic engine. See, unlike the LVM-3's current engine, this one burns a much denser mix of refined kerosene and liquid oxygen. And the result? Way more power from a smaller engine. It gives the rocket the extra muscle it needs to lift both of those heavy halves of Chandrayaan-4. And this is where a major conflict shows up in the plan. The mission is set for October 2027. But if you actually look at ISRO's own official calendar, the upgraded rocket that's needed for the launch isn't expected to be flight-ready until 2028 or maybe even 2029. I mean, you do the math, right? Those dates just don't line up. The financial data tells pretty much the same story. A parliamentary committee pointed out that out of 150 crore rupees set aside for the mission in the 2025-26 budget, only about 34.6 crore had actually been spent by early 2026. And the reason? Well, they deliberately held off on buying hardware because they were still trying to sort out the final design of that new rocket engine. So, while Chandrayaan-4 is this massive national undertaking, the very next step on the roadmap actually expands into a major international collaboration. It really goes to show that lunar exploration isn't a solo sport anymore. So let me introduce you to the LUPEX mission, which is also going to be known as Chandrayaan-5. It's a joint venture between India's ISRO and Japan's JAXA, and they're aiming for a launch around 2028. Its goal is to go deep into the moon's permanently shadowed craters to answer the most critical question for any future lunar settlement: just how much water ice is really there? What's cool is that the partnership really plays to each agency's strengths.
Japan is providing its powerful H-3 rocket and this really sophisticated 350-kilogram rover that's designed to survive the extreme cold. And India, building on that amazing Chandrayaan-3 success, is responsible for developing the precision lander that's going to get that rover safely to the surface.
So, okay, we've got sample returns, we've got new engines, we've got international partnerships. Now let's tie it all together and see how these incredibly complex missions are being meticulously designed to pave the way for putting an Indian astronaut on the moon.
And this, right here, is the crucial point. Nothing here is random. Each and every mission is a vital prerequisite. The upcoming Gaganyaan program, that's all about perfecting a spacecraft that can safely carry humans. An experiment called SPADEX is designed to master in-space docking, which you absolutely need to build a space station. We just saw how LUPEX is going to map water for life support, and Chandrayaan-4 is going to prove the single most critical capability of all, launching from the moon and getting home safely.
You see, every single piece is designed to build towards this one ultimate vision. These missions are the technological foundation for the Bharatiya Antariksh Station planned for 2035, which itself is going to serve as the final staging ground for that human lunar landing in 2040.
Look, the challenges are just immense. We're talking about untested engines, razor-thin timelines, and maneuvers that have never even been attempted by India before. But if you know anything about ISRO, you know they've built their entire reputation on frugal innovation and turning these daunting challenges into historic triumphs. The roadmap is clear. The only question now is whether this next giant leap will be its greatest one yet.